So example 2 is similar to example 1, but now we introduce variables. So instead of being part of the root 2 family or the root 3 family, this first one, everything is part of the root A family. In addition to simplifying it, the question asks us to say where it's defined. So this is a review from 2.2. You can say something's defined, right? What is not allowed for square roots? You're not allowed to take the square root of a negative, right? So if I put in positive values for A, that's okay, because then I'd have square root of a positive number. If I put in negative values for A, that's going to be bad, because then I would take the square root of a negative number. So as far as where this one is defined, it's defined only when it's positive. So we would say that A has to be bigger than or equal to 0. So first of all, we're identifying where it's defined. Where is it possible? Only when A is bigger than or equal to 0. Now when we look at this one, first of all, each individual radical is already simplified. It's already written as a mixed radical. There's no perfect squares inside the radical to pull out. And all three of them are like radicals. So if you go 6 of them plus 5 of them, you have 11. You subtract 11, you're left with nothing. So the first answer is nothing, 0. You wouldn't get any marks if you left it blank. You have to write 0, even though the answer is nothing. Wouldn't that be something? You had a test where all the answers were 0 and a teacher gave you full marks if you handed it in blank? Yeah, but you'd have to be very confident to hand it in blank and think that you get full marks. B. Yes?
Would you take marks if I wrote -0?
There is no -0. That's your favorite thing. All right, part B. We're going to look at where it's defined. This one has 2 variables. This one has 2 variables. We have to decide where it's defined for A and where it's defined for B. We're dealing with square roots, so we can't take negatives. Can you see that whether you put in a positive A or a negative A, that because it's A squared, it will always be positive? Okay? So the only thing that's going to cause us a problem here is the values of B. If B is a negative number, this whole thing is going to be negative, and that's going to be bad. If B is a positive number, it's going to be okay. Same thing happens in the second one. So when we go to our defined, A can be anything. B has to be bigger than or equal to 0. So in order to have a positive thing inside of our square root, A can be anything and B can be bigger than or equal to 0. These aren't alike in the inside. One of them has a 50, one of them has an 8. They're not the same. We cannot put them together. What we need to do first is simplify these radicals. Can you see that 50 is the same as 25 times 2? And I'd still have the A squared and the B. And can you see that 8 is the same as 4 times 2? And I'd still have the A squared and the B. What is the square root of 25? 5. Are there any variables that I could pull out? With a square root, you would need 2 of something in order to pull 1 out, right? And I have an A squared, so an A could come out. And then technically, because A could be positive or negative and a square root is always positive, we put absolute values around there. I am not going to be, if you would just leave that as A on a test or a quiz, I'm not going to be super strict. I'll put the bars there to remind you, but they're not, the curriculum's not worried that you for sure get the bars right in this case. This is the best answer, but if you just wrote 5A, I would accept it. And it's on video now, so if I take marks off, you can go to the video and say, no, you said in class that you wouldn't take off marks for this, so you guys are safe. And you're left with a 2 and a b on the inside. Again, the square root of 4 is 2. I can pull out an a, and I'm left with a 2 and a b. Again, this 4, square root of 4, becomes that 2, right? This 25, square root of 25, becomes that 5. Now we have written our radicals as mixed radicals, and they're simplified. And we notice that our radicals are the same. These are part of the same family, the root 2b family. So since they're both 2b, you can add them together. There's no any not 2b's here, so no English to do. 5 squared root of a minus that. 5 minus 2 will leave you with 3 of them. And that is our final answer. Finally, for part C, cube roots. What's the nice thing about odd ones for defined? They always work. So as far as defined, P can be anything. And Q can be anything.
Even -0.
We're not going to go to -0 anymore. So we're going to look at our numbers. Okay? In order to pull out a cube, can you do cube root of 27? Yes, that would be 3. We need 3 variables in order to pull out one, p cubed. So we can pull out a p, and we're left with, the only thing left inside is a cube root of q. Same thing here in the second one. There's p cubed inside the cube root, so we can pull out 1p, and the only thing we're left with is a q. So these are like radicals because the family is the cube root of q. And if you had 3p's plus 8p's, you would have 11p's, cube root of q. Okay, questions 5 and 7 you can do with this one. We'll start Thursday's class with example 3. Remember your test tomorrow.